Welcome everyone. I am C.SAMPATHKUMAR, Assistant Professor, Department of Mechanical Engineering, Rogini College of Engineering and Technology, Palkulam, Kanyakumari. In this video, we are going to discuss about the subject ME8595 Thermal Engineering 2. In this, we are going to discuss the Unit 1 Steam Nozzle. The outcome of the unit is they explain the types of a nozzle and apply the concept for different velocities through a nozzle. For this, the highest community level is K3, which is analyzing. The syllabus of steam nozzle is the types and shapes of the nozzles, flow of steam nozzles through nozzle, critical pressure ratio, variation of mass flow rate with pressure ratio, effect of friction and metastable flow. Now we are going to discuss about the introduction on a steam nozzle. First, a nozzle is a duct of a smoothly varying cross section in which a steadily flowing fluid can be accelerated to a high velocity by a drop in pressure of the fluid along the duct. But a steam nozzle can be defined as the passage of varying cross section through which a heat energy of a steam is converted into kinetic energy. A steam nozzle functions is the major function to produce a steam jet with high velocity to drive the steam turbines. The diagram shows the nozzle where the area of cross section is decreasing from entrance to exit, where the velocity of the fluid is increasing quietly, but the pressure drop and the temperatures or drops vary. Types of nozzles: the first one convergent nozzle, second divergent nozzle, then third one convergent divergent nozzle. First we are going to see about the convergent nozzle. In this, cross sectional area is decreasing continuously from entrance to exit. This shows the velocity of a fluid flow is increasing. It is used in a case where the back pressure is equal or greater than the critical pressure ratio. Now the divergent nozzle. In this, the cross sectional area of the divergent nozzle is continuously increasing from an entrance to exit. It is used in a case where the back pressure is less than the critical pressure ratio. The back pressure always opposes the fluid flow. The critical pressure flow is accelerated to a velocity equal to the local sound of a sound in the fluid. The diagram shows the divergent nozzle. Then convergent divergent nozzle. Here the cross section first decreases from an entrance to the throat and then increases from throat to exit. It is widely used in many steam turbines. The diagram shows the cross sectional area is decreasing from an entrance to the exit throat, where then the throat to the exit it is increasing. First the convergent, then the divergent, then the center portion which interconnects the convergent divergent is called throat. The shapes of the nozzles. At supersonic speed, the Mach number which is less than 1 decreases the area increases the speed of the flow. In supersonic flow, the Mach number is greater than 1. The effect of area changes difference. This diagram shows the Mach numbers where is the less than 1 is supersonic and greater than 1 is supersonic flow. Now the flow of steam through nozzles. In the convergent portion, the steam enters the nozzle with a high pressure but with a negligible velocity. But there is a drop in a steam pressure with a high rise in velocity. There is a drop in the enthalpy or a heat of the steam. There is a drop of a heat is utilized in the joining of some external work but converted into kinetic energy. In the divergence portion, where further there is a drop of steam pressure with the further rise in the velocity. Again there is a drop in the enthalpy or a total heat of a steam which is converted into kinetic energy. The supersaturated flow or a metastable flow in the nozzle. As the steam expands in the nozzle, the pressure and temperature drop as it is like a steam start condensing when strikes the saturation line. But this line always is a situation due to the high velocities, time of which the steam resides in the nozzle is small, and there is a sufficient time needed for a heat transfer and the formation of liquid droplets due to the condensation. These are the flow of steam through nozzles. Now the critical pressure ratio. The pressure at the section where the sonic velocity is attained to the inlet pressure of a nozzle is called a critical pressure ratio. This shows the convergent divergent nozzle where the Mach number is less than 1, which shows the subsonic flow, and where the Mach number is greater than 1, which shows the supersonic flow. When m is equal to 1, which shows the portion of throat. At throat where the M is equal, Mach number is equal to 1. Then effect of back pressure on a flow through a convergent nozzle, where the graph shows the between the pressure and the mass flow rate of the fluids. PB was PO was the convergent diversion nozzle. Note the mass flow rate increases with the degrees of PB and PO, reaches the maximum pressure at PB equal to P star and remains constant for PB by PO values less than the critical ratio. As illustrated in the figures, the effect of back pressure on the nozzle exit pressure, we observe that PE is equal to PE for a condition PB is greater than or equal to P star, where the condition P star is equal to PB is less than the P star. Now the effect of friction in nozzle. The effect of friction on a nozzle efficiency. For steam flowing to nozzle, it is a final velocity of a pressure drop. It reduces the friction between the nozzle surface and a stream and the internal surface of a stream itself. The shock losses, most of the frictional losses occurs between the throat and the exit in a nozzle, producing the following effect. The expansion is more isotropic, the enthalpy drop is reduced, the final dryness fraction of the steam increases, that is the kinetic energy heat due to the friction and gets absorbed. The specific volume of a steam increases. The steam becomes more dry due to the friction reheating. The metastable flow, which is the flow between the theoretical saturated line and the actual saturated line, is called a metastable flow or a supersaturated flow. The temperature difference between the supersaturated temperature and the actual temperature is called a degree of subcooling or a degree of undercooling. The diagram shows the metastable flow where the convergent divergent nozzle. Then applications of steam nozzle: steam and gas turbine, jet engine, rocket motors. It is used to discharge the fluid, vengeries, injectors for pumping feed waters to boilers. Supersonic gas turbine for intake and pressure requirements of the engine is high. Rockets and for removing the air from a condenser using the injector, spray painting, steam jet refrigeration system. These are the references used for making these PPTs. Thank you.